Okay, hello everyone. My name is Jan Krämer and I'm Professor of Internet and Communications Business here at the University of Passau. And today I have the great honor to announce the talk by Professor Hemant Bhargava in our keynote series on digital platform ecosystems. Professor Bhargava is Professor of Technology Management at the University of California, Davis, and also Director of the Center of Analytics and Technology in Society at UC Davis. And he's also a distinguished fellow of the Informs Information Systems Society, among many different other roles he's fulfilling. Professor Bhargava is a renowned expert and academic leader in economic modeling and analysis of technology-based businesses and markets, and especially also digital platform markets. And we'll get a glimpse of that today. And he's published extensively in the top journals of information systems, operations management, and also marketing. And also currently he's serving as a department editor at Management Science, which is one of the most prestigious journals in management studies. So I'm very much looking forward to his talk. Hemant has this extraordinary gift of formalizing industry structure and competitive dynamics in an elegant analytical way. And he will share one of these models today with us, and particularly on digital platform ecosystems and business strategy in this context, and how multi-sided digital platforms, in particular advertising finance digital platforms, can best motivate external value creators to contribute to the platform. Just a quick housekeeping remark before we start. This session will be recorded. The talk will be recorded. You can ask questions through the chat function or the Q&A function, and we will take them as we see fit. We will mostly, during the main presentation, only take comprehension questions that are very urgent. And afterwards, the Q&A session will not be recorded. And then we can take questions as we see them fit, and we might unmute you, but then you will not be on the record then because the presentation, the recording has stopped. All right, without further ado, Hemant, the floor is yours.
All right, thank you so much, Jan, for the introduction, and good to meet all of you who are here. And it's really a pleasure to be with your group. I know you have been doing a lot of these seminars and collecting some really diverse and interesting bit of knowledge. So I'm really pleased to be able to contribute to that. So yeah, the topics you described, part of that actually is a recent interest in the last 2 years to look at how to start modeling the fundamental mechanics of platforms and ecosystems, because I think a lot of this thinking was motivated by some conversations I've participated in various different forms, interviews and other things in the last 5 years about the power of platforms, potential need for regulating platforms. And I know this is very strong in Europe as well. So the motivating point was that it would be really hard to systematically and carefully discuss how to regulate platforms, whether they are powerful, whether they're abusing their power, and so forth, without having some kind of rigorous mechanism to study those issues. And the issues I really want to talk about are issues of platform scale, because that's obviously related to power and abuse, but also issues of codependence in a platform, among the platform itself and other participants in the ecosystem. So that's something fundamental that I wanted to include and model. And of course, issues of platform design, and then finally, how all of these things interact with each other, right? So I think this is a series on digital platforms, so I don't need to introduce the topic to you, but just to be sure we're all on the same page, I am going to think about platforms as these systems, markets, right? So different aspects of it that orchestrate interconnections between multiple sides, right? And these sides, I'll apologize, I'll be using different terms throughout, which is very hard to just stick to one term. So occasionally I'll say users and complementers. Other times I might say producers, creators, and so forth. But the point is different types of platforms have role to orchestrate among different sites. And this orchestration or these interconnections that are created are the ones that create values, right? So of course, people come to the platform because they see some value, but the point is that predominantly the value is being sourced from third-party or external creators or complementers, right? So that's my view of a platform. And in analyzing this, my goal is to study how these issues of scale and power are influenced by attributes of the complementers, attributes or design choices made by the platform. And these could be economic choices, for instance, the type of contract there is, and technical choices that affect functioning and features and so forth. And third, market structure, right? So how all of these things are interconnected, how does the structure of the ecosystem itself affect how power is distributed and how revenue is distributed between the platform and complementers and maybe between users. So that's the point about codependence and how this codependence, this ecosystem structure will evolve over time, right? So these are my broad goals. As I said earlier, some of it was motivated by these headlines that we have seen over several years, or at least, over 5 years that I've been involved in these conversations, but I just thought I would show you a few recent ones that are all hinting at different types of tensions among different types of platforms. So in the US, starting a year before the elections, this whole issue of platform power became very, very front and center in Congress, in the press, and other forms. We know there have been some interesting cases, lawsuits, for instance, the one between Epic and Apple, the one between one antitrust case involving Apple and Google partnership. A lot of people complain about Amazon's treatment of third-party sellers. So that's the complementers on the Amazon marketplace and so forth. So as I mentioned earlier, my point is that to really analyze these issues carefully, you need a rigorous understanding of how these ecosystems work and how these different parties connect economically with each other. So today I'm not going to talk about these issues so much, but my goal in these last 2 years has really been to build a modeling foundation through which one can deeply understand the mechanics of these platforms, and then to build a foundation that can be applied in so many different ways to answer a variety of questions. So today, my goal is to give you that architecture and also apply it in a couple of different settings. And, I think since we have about 35 to 45 minutes, I'll be going through this pretty fast, but there are 2 papers that I'll refer to, which you can read for details. But here are a few examples here. So, we are all familiar with Netflix. And by the way, I will be loose. A lot of people have issues of definition between platforms and aggregators. I'm going to be loose about that because my work applies to both categories. So I really will not make that distinction at all. So for instance, we know about Netflix. The 2 sides are subscribers who pay Netflix a fee every month, and then the producers of content that Netflix sources from, besides its own original content. And similarly in TikTok, we have viewers and creators. In Airbnb, as you know, you have guests and hosts, and of course there's Amazon Marketplace. These are different types of platforms if you think of not only who's involved, but the revenue model for these platforms, right? So in Netflix, users, subscribers pay a monthly access fee for the bundle of content. On TikTok, it's free, but its sourced revenue is from advertising. Airbnb gets a cut of the bilateral trade that occurs between the guest and the host, and it's similar with Amazon. And what's common in all of them is that there is some kind of revenue sharing arrangement in which the contributors, the complementers, are paid according, roughly proportional to what they offer on the platform, right? So on Netflix, there are back-end arrangements. On TikTok, again, creators who become successful enough get a share of advertising revenue. On Airbnb and Amazon, it's a little more formulaic. But overall, with some approximation, every creator is being paid a share of the revenue that the platform sets aside for complementers, and then further according to the share of their contribution to the platform. So in building this model, I want to focus on codependence, as I mentioned. And the codependence is that both the platform and complementers rely on each other for value creation, right? So the platform attracts users, but the platform really doesn't provide everything. It's the complementers who provide the value. But complementers rely on the platform for many things besides infrastructure, marketing reach, and so forth. So there's that codependence. And obviously this codependence, the balance of it will change across time. It will change depending on the scale of the platform. And in particular, this can endogenously be affected by choices made by all of these players, right? So my goal is to build a model that is able to address all of these pieces. Of course, those of you who have built mathematical models involving multi-sided network effects and feedback loops and so forth recognize the complexity involved in doing that. And as I said, my goal is to build a model that can really be stretched to do many, many different things. So there were some very fundamental modeling choices that were made in order to make this work. And of course, the goal is that this should be tractable. It should be realistic, right? It should not be tightly constrained to only very tiny, parameter regions that work. And it should provide useful, interesting answers that make sense, right? So I hope I can show you a little bit of that in the next few minutes. All right. So this is the basic setup that we will think about platforms. There are multiple sides I'll start with two sides. I'll give you this other case with advertisers being the third side, but that's really not so fundamental how many sides there are. It's still the nature of the connections between them. So, of course, a platform has millions of users and they're very heterogeneous. And many platforms have thousands, hundreds of thousands of complementers. So the first goal is that there should be a model that works in the large scale, right? So the way I'm going to think about it is I'm really not terribly interested in the actual bilateral connections. I don't care about which user might connect with which complementer. So that's a modeling choice, or it translates into a modeling choice of looking at things somewhat in the aggregate. At the same time, given the questions that we discussed, we are interested in micro details about the complementer or the creator side. And so the way I'm going to think about this is there are multiple complementers whom I will index with I or J on some of my slides. Their output or contribution to the platform is denoted by Q sub I. That output could be digital content, it could be products, it could be movies or other digital content, as I mentioned. And I'm really going to think of the output not in terms of necessarily the effort put in by the complementer, but in terms of how much interest it attracts on the user side of the platform, right? So higher QI means it's more popular or more attractive or brings in more views or more users and so forth, or there are more trades that occur. Counterpart to the Q sub I is the C sub I, which I will think of as the unit cost of producing content that attracts a unit view on the other side of the platform, right? So we have heterogeneous complementers. I will index them all according to the cost attributes that they have, going from low to high. So low cost complementers are the ones that are stars or celebrities or powerful creators, so that if they put in a certain amount of effort, they will get enormous interest on the user side of the platform. High-cost complementers are those for whom that same effort would produce very few views. All right. And I'm going to do this in a deterministic manner. You could add uncertainty to it, but for the kinds of things I'm going to analyze, it's really not important. So I'm going to think of this as a fully deterministic system, right? So we have complementers with some index of costs. And based on those costs and many other attributes that we'll discuss, they will decide to contribute QI content, right? So that's the value being created. Users consume these products, this content, somehow revenue is returned into the platform. A shared gamma of revenue is given to complementers, and the remaining share 1 minus gamma contributes to the platform's profit, right? So as we think about it at the very high level, I make one of few design assumptions for the model itself, right? So the first point is that for the platform as a whole, its interest on the user side is an increasing function of the total amount of content offered on the platform, right? So for instance, if you're thinking of Netflix or a TV bundle, the idea is that the total demand for consumption of TV content is stretchable, it's elastic. If there's a lot more shows on our TV channels, people on the average will consume more time watching TV, right? And we've seen that over the last several decades, and we all know about that. So total demand, even at the same price, is elastic in total volume of the scale of products that the platform attracts. Of course, it's diminishing with, it's increasing with diminishing returns. So you have that concave form over here. Demand for the platform, of course, is decreasing in the price that the platform charges. So this is the price P that might be charged to the users, or it might be some kind of other tax, such as advertising, that is imposed on them, right? So it's total demand is decreasing in this. So those are trade-offs that the platform has to make. That leads to some kind of surplus that is generated by the platform. And again, the important thing is that this surplus is increasing in terms of the total scale of the platform. And of course, there is some kind of unimodal behavior against the price offered by the platform. And finally, turning to the complementer side, as I described a few minutes ago, the share of surplus that every complementer gets is based on the gamma, the fraction that the platform returns to complementers. And on top of that, the share that each complementer contributes to the total amount of content or product on the platform, right? And then creators or complementers have the cost of offering content on the platform, right? So this is the basic economic engine that I've formalized or created over here. And let's see if this can work and give us enough insight and results into how the platform system operates, right? So that is my goal for the next few minutes. Let me get out of this. All right. Okay. A little bit of note about how the platform and its complementers and the users, of course, interact. So we can imagine that, in terms of the stickiness or long-term structure of certain things, the design of the contract and certain elements of the platform's design are set first. So that's how the platform operates and how it relates with complementers. Given this design and given their own attributes, complementers make decisions such as whether to participate on the platform or not, and how much content to offer. The platform may have further short-term decisions that it can control, such as price and advertising. And then all of those things together determine the success or scale of the platform in the market. That in turn generates revenue to the platform, which, as I mentioned earlier, is shared with complementors, right? So complementors then are making choices based on their attributes, the design of the platform and the contract, and their expectations regarding how much cost and revenue they would obtain by making certain choices, right? So that's really how I will model and then solve this system. And I'll do it in two different parts. So the first part, you can think of a platform or aggregator like Netflix, which has multiple sites, in this case, users and content producers, and which is creating revenue through a subscription pricing approach. So that's, I call it pure bundling. So the platform offers a bundle of content for, I think in the US for $10.99 a month, different rates in other countries. Gym Pass or Class Pass, Movie Pass, these were a few other companies that tried to replicate this idea by offering a monthly fee for access to hundreds of gyms, in this case, that were participating. Quibi, of course, was very interesting for a few years and it failed, but the goal of Quibi was to collect short form video content up to 10 minutes long and offer it to subscribers at a monthly fee. So these are similar platforms. And of course, the fundamental idea is that they all aggregate output from many, many different producers. And so this is something that was covered in a paper that has been online at Management Science for the last year. And I think it just got published in print in April. So I'll give you a flavor of it just to set the stage for the second part. And of course, I welcome you to go and read more details in the paper itself. So let's see how we extend the broad modeling foundation I described into this particular case. So here's the same picture that I showed you before. And then the important thing here really that pertains to the bundling part is that we'll think of the demand for the entire bundle as this function, which I will not stretch too much, but I think this is the important part in this other paper, which you can read in print. If any of you have worked on bundling, as you know, it gets very, very complex as you start looking at the value of bundle for comprising many different components. It becomes easier when you only think about pure bundle, because then all you care about is the queue, right? The components of it don't matter so much in my case. So I basically have a particular downward sloping demand function that I think really represents the bundle case very well. The model would work with many other demand functions. So the important thing is simply it's a downward sloping demand function and price, right? So this is demand and price. The platform's profit is, as you would expect it to be, as I described, the share 1 minus gamma, which is what the platform keeps for itself. The revenue, which is the price minus the platform's cost, times the volume. And that leads to a surplus that is created in this ecosystem, and then it's shared with the producers, right? So this surplus goes into the producer's function in the way that I had described it to you previously, right? So this is all very straightforward. As you can see, there are very few assumptions of detail, right? The only thing that's important here is this abstract idea that we can think of complementors as being indexed by their capabilities or costs, right? High capability would mean low cost. And capability could be technical skills, it could be production technologies. I gave an example in one of my papers about Disney, the technologies with which they use to create the Mandalorian series, some really amazing immersion technologies for creating content. It could be availability of stars that are signed up to you, or other talent, availability of scripts. In the case of movies, you have access to certain characters or stories. So all of those things would mean a low CI, and then people like us who are trying to produce content would, for us, the cost of getting the same number of views would be relative, clearly much higher, right? So it has all of that. That's really the fundamental thing that I need for this model to work. All right. The decision making is like I described before. So complementers will decide on their QIs, and then collectively, the Q will be a summation of all the Q sub-Is. And this is another abstraction because now it is saying that different types of content can be added in a certain way regardless of what it is. And I made that choice very consciously because in a large platform, so when you think about bundles, you worry about correlation between additive, sub-additive demand, whether things are complements or substitutes and so forth. And my thinking is that in a very large bundle or in a large platform, if you want to go in a general direction, there are going to be all kinds of things. There are products that are competing with each other. There are substitutes. There are products that complement. So you might be selling tennis rackets and tennis balls, but you could be selling tennis gear and soccer gear and other things that perhaps compete with each other, or tennis and music. Everything exists on the platform. And in that sense, this idea that total demand, which is what I described earlier, right? That total demand increases with Q because as you add more things, you add music and sports and entertainment and news and politics and so forth. It keeps bringing more and more users, viewers, whatever that might be, to the platform, right? And so our time to some extent can be stretched based on how much product there is. But eventually, of course, time is finite, budget is finite, and so forth. So you get the diminishing returns part of it. All right. So yeah, let's see so this is the model. And the rest of it is to then, execute, solve the model and see what kinds of results we get, whether those are interesting, novel, insightful, whether we can get them quickly. And that's one of my goals, to show that a lot of different things can be, the levers of the model can be turned quite easily to produce many different types of results. And by the way, I'm doing this analysis with a monopoly platform. I have done this work, but not fully written and published. It can easily be extended to competing platforms, because ultimately that's what we really care about when we talk about platform regulation and so forth, right? And the idea of extending to competition is fairly straightforward. I just need to break up these demand functions according to what each of the contributing platforms would get. So I have done it for symmetric platforms, and it's very, very straightforward. But I will not be talking about that right now. Okay. So the first thing is, it's pretty straightforward, or there is some math and analysis involved, but you get the equilibrium in a fairly systematic way. And in this case, as I said, there are different parts of the equilibrium or the decision making. We are really not terribly interested in the prices set by the platform for what I'm looking at. But that's fairly straightforward to compute. And based on that and the demand function, you get surplus. The thing I really want to focus on with these models is the complementer side. So in the equilibrium and with the modeling setup that I described, you can decide what is the mass of complementers that works with the platform. And what this equation is telling us is basically there will be a collection of complementers who are below some cost threshold, right, that will participate. And where that threshold lies really depends on the distribution of these costs. So if you have a bunch of complementers with certain costs, and then the next one is a much higher cost than that, right? So there are some, let's say, professional content producers, and then amateurs who are quite different from the professionals. The idea is that most likely the professionals or some subset of those will survive in this case, and the amateurs may not be able to, or if they do, they have really tiny contributions that will be ignored, abstracted out in this case, right? Or if you have some other distribution. So basically, I'll show you a few plots to show what that means. But the important thing is that given an abstraction of these cost indices, you can actually very systematically and in a precise way compute which complementors participate, how much content they offer, which you can see here is a decreasing function of their cost index, as it should be. And then, of course, the total amount of content available on the platform is computed, right? And it's a function of all the different parameters that were imposed. This is coming from the demand function on the user side. These are the cost indices on the complementer side. Gamma is the revenue share, and theta, which I did not focus on much before, but remember I said this is demand for the platform, and Q. And theta is basically some, in this case, it's the curvature. So it's basically the stretchability of demand to the total amount of content. So here we have a mathematical form of the equilibrium. And then as you dig into it further, it can provide these different insights. And some of those I will talk about. There's a lot more in the paper. All right. So one of the features of the model is that even though I have a linear cost function for complementors, right? It's the CI times Q sub I. You still get a case where, so normally with linear cost functions, you would, obviously you can see that the low cost creators always have a lower cost no matter what volume you're working at. So you would expect a bang result or a single creator outcome where one creator can capture all the content. And that's not the case here. I think I have to speed up, so I won't explain that in too much detail here. The higher theta, meaning if demand is extremely elastic to content, it leads to lower creators. Because what happens is that the low-cost creators get extremely aggressive to produce content. Otherwise, the theta, which is between 0 and 1, or between 0 and 2/3 actually, that restricts the aggressiveness of creators. Because if I produce more, my marginal revenue is decreasing because total demand has this diminishing returns feature. And other creators also producing, right? So that this competition or competition between creators is what controls how much they make. Let me move on to this. It's easy from here to look at the equilibrium under different market structures. So what if some creators merge? What if creators form a consortium and get rid of the platform like Hulu, where they go directly to consumers? What if creators start offering products directly? Some creators start offering products directly to the market. And in particular, what happens if the platform gets into the business of creating content, right? These first-party complements. So all of these things can be examined very quickly with this architecture, and I will not give you the results. Again, I invite you to read the paper. I also get some interesting insights on the revenue sharing tension between creators or the complementers and the platform. So for the platform, it's pretty straightforward to see that as the platform increases the share or modulates the share that it provides to creators, there is some kind of increasing and then decreasing response function, the platform's profit. If gamma is 0, creators get nothing, so they don't produce anything. If gamma is very high, then creators get they keep all the gains from the value that is created, right? So for the platform, the optimal gamma is somewhere in this region between 0 and 1. If you look at it from a creator's point of view or complementer's point of view, it might look like the bigger the gamma, bigger the share, they are better off. So maybe creators want a gamma of 1. But that's not really the case. And this is getting into the codependence between the platform and complementers. Because for somehow, if the market power structure is such that gamma tends to be very high, then what will happen is, just like complementers, the platform has a cost index of making its own content, right? And it may have certain fixed costs before it can do that. But the point is, the higher the gamma, the higher the threshold at which the platform is willing to enter. So even if its cost index is high relative to complementers, if it's not getting any share of the revenue, it may then wish to enter as first-party products directly. And the threat of the platform's entry, which then is really detrimental to complementors, will cause complementors as a whole to moderate their demand for gamma for the revenue share. So in terms of the ecosystem overall, you can see that there could be some disagreement between the platform and complementors, but that disagreement would be in a relatively narrow range. And of course, it will be different for different platforms. But there are parameters each side controls that can tune the nature of disagreement, and it may not necessarily call for a heavy-handed regulatory approach. It might be things that the market can modulate by itself. Right? The dynamics is something I am interested in that we'll maybe very briefly talk about at the very end. All right. The second part I'm going to look at, so I'm pivoting now to the case of advertising-driven platforms that Jan mentioned in the introduction. It's got a very similar structure as I described so far, except now in this case, the revenue is based on advertising. And so the introduction of advertising creates a few other mechanical elements that work a little bit differently. I will have to speed through them in the interest of time. Sorry, I should go back for just a second if I can. Yeah, the details you can read about in the second paper that should be, is forthcoming in Management Science, should be available online in a few months, but I would be happy to share it with anyone or through Jan if you're interested. Okay, so the setup is similar to what we have before. You have creators with their cost indices. We have the platform. There's a slightly different demand function now for the platform. But again, the demand by viewers, will be dependent on the total content offered by creators, and now also on the advertising revenue that will be generally serves as a negative effect on total viewership. So we'll not go through the details in this case. There is a particular advertising function that I use, but again, it's not terribly important. You need something to get the computations. It's basically a downward sloping demand function from the advertiser side, right? So the higher the price per ad, per viewer, lower the demand. Okay. So similar decision-making sequence as in the previous case. So once again here, the first thing I will do is in part one, we had the subscription price, which we solved for. Here we'll first solve for the advertising price. Turns out a little more messy than in the other case, but it still works out very nicely. I will show you all this math just to tell you that it exists. And maybe if you can spot some of the connections between the variables. But again, after solving for the advertising and plugging that into the revenue function, we can get the overall equilibrium for the creators, right? And it's a very similar output to what I showed you before, except now the revenue part, which is the gamma P star A star, is the advertising revenue rather than the subscription-based revenue that we had previously. This is something I had mentioned earlier. So in this picture on the top panel, you see these are the creators and the different cost indices, and you may not see the dots I have over here. These are a few creators with very low cost index relative to everybody else, all right? And the blue curve is simply the CDF. So you don't see the part over here, but then the rest of it is going up like this, right? So given that a few creators are really very powerful and different from everybody else, the content that is provided is, you can see here, those three creators are in the ecosystem and they capture all of the content. The dots are telling you the share of their content, right? And then the third picture is just for a different theta, so we'll ignore that for now. Here are a few other examples. One second. Right. So in the remaining examples, you have different distributions of these cost indices, and that leads to different numbers of creators, and the dots again representing in the second panel, the vertical axis is each creator's share of the total content that is offered, right? So you can see how the cost distributions affect who participates and how much output they contribute. And this can be worked out so that if you were to look at a particular platform and try to understand the nature of, its scale, its concentration among creators, and then eventually these issues of codependence, that can be worked out. We can further look at certain design elements about the platform and see how can the platform influence how this whole ecosystem works. So for instance, in this case of platforms that depend on creators and source advertising, revenue through advertising, you can see the effect of if they invest in certain types of toolkits that help creators. Are these toolkits going to change the cost structure of creators who already had low cost, or are they going to affect creators all creators in a certain way? And we can show that actually for the platform, it would be ideal to have programs and toolkits that predominantly help the higher CJ creators who are not the ones producing most of the content for the platform, right? So it's sort of leveling the playing field is more helpful for the platform in terms of the total content that becomes available, and then eventually in these market power games for distribution of revenue between the platform and its complementers. There are other pieces that, again, I will skip in the interest of time, but one can look at different elements that the platform can perturb and look at their effect on profits and then on the parameters that define the ecosystem, right? And some of those may have trade-offs. Certain things may actually be win-win-win for all sides in the ecosystem, and that can be analyzed here. I'm going to skip this entirely and focus on this issue of revenue sharing and what I talked about earlier, the dynamics of codependence. Because I'm trying to move away to where we started in the introduction with these issues of platform power, abuse, and regulation. So with the modeling architecture I gave you in the last 30 minutes or so, we can actually take these platforms and if you could quantify some of the abstract parameters that I described, then you get an understanding of how these platforms work and what their scale would be and how much power they might have. We know that there is some codependence, right? As I mentioned earlier, they both benefit from each other. And the platform knows in general that if it improves the experience for both complementers, users, or whatever sites you have, the platform itself is better off. If it can attract more producers, that helps the platform. If it attracts more users, of course, that's great. So at some level, the platform does not have an interest in destroying producers or complementers, right? The question is there a way to find this common ground? So initially, of course, when these platforms start, they are extremely dependent on third-party complementers, right? So when eBay, started, they desperately needed sellers, right? When TikTok wants to attract users, they desperately need celebrities who offer these 10-second videos. Of course, everybody can offer them, but the predominant demand, predominant consumption is based on what influencers, stars, celebrities offer. So platforms need these complementers, and they need them desperately at the start. Over time, though, and so initially their design preferences are common. They both want, growth, scale, and so forth. Over time, these design preferences may start diverging. In particular, when the platform is growing, there's more for everybody. There's more revenue for the platform, but there's more revenue for complementers. When you start hitting saturation is where trouble starts happening, because the platform is still driven to grow more. And now the only way to grow its revenues and profits is not by scaling up. So it's no longer simply by scaling up, the platform now needs to start getting more of every dollar, every monetary amount that is created through this interaction. So now you get tension between the preferences of users and the platform, for instance. So over time, the platform wants more advertising to go along with the content, or you may find tension between the platform and creators, right? So the platform wants a bigger revenue share, or if it cannot get that, maybe it starts moving into first-party products, as we have seen with Amazon and other platforms. So in a sense, we can think of these different phases, and this is where some of the parameters in the model would change. So we've talked about this first phase, the middle phase, where the pie is still growing. There's still codependence, but everybody's still okay. And then a third phase where these tensions start emerging, and the platform really cannot increase its profits any longer without hurting somebody, right? So this win-win-win honeymoon phase is over. And the question then is, where do we go next? So what I showed you on the previous slide, to a large extent, these can be quantified now with the architecture that I have. The question is, where do we see this going over time? Is as platforms get more and more tensions within the ecosystem, does it mean that the whole ecosystem structure will dissolve, right? That will the platform start? And we see that happening, for instance, in the case of Netflix, where a company that was entirely dependent on third-party producers 10 years ago is now positioned primarily as a company that offers its own content, right? So it's dissolving that structure of codependence and saying, look, I cannot really be profitable if I rely on third-party participants. I'm going to make my own products and make them attractive to users. So the question is to what extent that might happen with platforms, right? Will this ecosystem structure change, and will the platform find it better, like Netflix, to become an original content platform? Or is it really going to cherry pick a few cases and let other complementers thrive? So maybe in 1% of products that Amazon sells, they actually have an interest in entering those markets and making their own products. But 99% of producers are really left alone, right? And in general, I think this is if you think of why platforms exist, it's because in many, many markets, we have extremely volatile demand, right? It's fickle, it's maybe not even predictable. And most producers, on the other hand, have created systems that have very stable supply, right? And if those producers were selling directly to consumers, then there is this mismatch between smooth supply and very unpredictable demand. And what the platform does is it really aggregates all of this, to some extent smooths out the risk, but it also pushes out all the risk to the complementers. So if there is such risk involved, and if the fundamental business model of the platform is really to outsource the risk and then to monetize all the success cases, right? So if on an iOS system, there are 100,000 apps that are created, or maybe 1 million apps that are created, 90% of which have no market. But the platform can generate revenue from the 100,000 or 10,000 that do, right? So that's a really wonderful business model. And why would a platform then want to destroy that by overly attacking its complementers, right? So some of these tensions arise, yes, because of that saturation in scale, and there is pressure to grow and improve profits. So platforms will push at the boundaries and poke at complementers or at users. But I feel in a majority of cases, that will be self-regulating, because going too far is going to change the structure of the platform. Netflix does it because, and this is something I've shown in an earlier paper on bundling about 8 years ago, it's really, really hard for an aggregator who entirely relies on third-party products to offer a bundle in particular. The bundling business model doesn't work when you're bundling somebody else's content. It doesn't work very well. And so that's something that Netflix recognized 8 or 9 years ago, and therefore went into building its own content instead of being hostage to all the other major studios and producers, right? So that's an exception. For the most part, I think a lot of the platforms that we talk about and we discuss in these, actually Netflix is not, it's so interesting, Netflix is not on anybody's radar in terms of moving into first-party content, right? Whereas Amazon and other Google and other companies are. So it's really interesting that a company that actually gives up that business model and moves is no longer of interest to regulators or those who are complaining about platforms. In general, though, I feel this is a self-regulating system. It will depend a little bit differently on transaction versus innovation platforms. They have different value propositions that they offer to different sides of the market. But in general, I think this is something that we can now study with a rigorous model. And that's what I have tried to present to you here. So there was in my own mind, a tension between presenting the model and results and keeping it more general. I have tried to kind of tread some both of those grounds, which may get confusing, but that's why we have this Q&A phase. I'm very happy to get into other details as we go through it. But just to recap, what I have tried to give you is a pretty general modeling foundation to study mechanics of platform ecosystems. You can see in the papers, it's very tractable and it's quite extensible. As I give you flavor of it, you can ask a variety of questions and tweak the model to answer those questions. And at least in the two cases that I've discussed so far, we get results that totally make sense. In some cases, they're insightful for both subscription-based and ad-based platforms. And my goal is to try to apply this architecture to a few other cases and see if it still continues to work. All right. So I'm going to pause here and be happy to take questions.